Hi all my YouTube viewers, it's Crystal here. I'm here because I wanted to make another video for you. The last few videos I've been using deep learning techniques to predict on the price of Bitcoin. So now what I'm going to do is I'm going to predict on the price of Bitcoin, but I'm going to use sklearn's MLPR. That's a multi-layer perceptron regressor. sklearn has a neural network, and the MLPR and the MLPC are their two neural networks. And since this is a regression problem, we're going to be using MLPR because I just wanted to see what the outcome would be using sklearn, because maybe a person doesn't feel comfortable using TensorFlow. So I wanted to show another way to predict on Bitcoin's prices just using sklearn. So I have created this program using Jupyter Notebook, creating a program in Python using Jupyter Notebook. And after we've created our Jupyter Notebook, the first thing that we want to do is we want to import our libraries. So we're going to import pandas as PD. That's going to create your data frame, and it's also going to process the data. We're going to import NumPy as NP, which creates a NumPy array, and it performs numerical computations. We're going to import datetime. That's going to timestamp the date columns. We're going to import math, which is going to compute mathematical computations. We're going to import sklearn, which provides your machine learning framework. And we're going to import matplotlib, which visualizes the data. And then finally, we're going to import sklearn, which visualizes the data statistically. So then after we have imported our libraries, what we want to do is we want to create a data frame from the time series data. You can get the time series data if you just do a search on Bitcoin prices. You should be able to find the time series data because I'm not able to show you the time series data because I'm using a free free movie maker, and this free movie maker will only allow me to use one tab, but I don't remember the name of it. But if you just do a search on Bitcoin prices, you should be able to find the Bitcoin prices, and then you have to download it and save it into your drive to use it, which is what I've done. And I've created a data frame called DF. And on this data frame called DF, you've got start, end, open, high, low, close, volume, and market capitalization. That is your data frame. And then what we're going to do is we're going to check out the information contained in the data frame. So the first two columns are objects, and the rest of the columns are numeric. Then we're going to check to see if we have any null values. Fortunately, we don't have any null values to impute. If we did have any null values to impute, then you would have to use pandas to impute those null values, because you would have to impute those in accordance with the dictates of time series analysis. So now what we're going to do is we're going to timestamp the end column. So we're going to use datetime to do that, and that's a pandas function as well, but we will use datetime to do that. And then after we've timestamped the end column, we're going to define our features. The two features that we're going to be using are the end column and the close column, and we're going to create a data frame called closing BTC equals DF features, and you can see closing BTC here. Now what we're going to do is we're going to use matplotlib to plot the time series data. And when you plot the time series data, you can see that it's plotting it all the way from 2021 to 2024. We've used Seaborn to create a histogram, so you can see where the data lies within the histogram. what the distribution is. So now what we do is we just use Matplotlib to plot the data for the 2023, and you can see what the data, the time series looks like in 2023. And then after that, we plot the time series from October to December in 2023. That's a 2-month period. So you can see what the time series looks like in that 2-month period. So now what we want to do is we're going to use stats models to perform a seasonal decompose, and we're going to do multiplicative decompose and additive decompose. And if you like statistics and you like analyzing time series data, then you can do that with the decompose. So with the multiplicative decompose, you're going to get your trend, and then you're going to get your season, and then you're going to get your residual. With the additive decompose, you're going to get your trend, you're going to get your seasonal, and then you're going to get your residual. So that's something that you can study on your own, that just to find more about trend in seasonal and residual. And that's with stats models, and that's something that you can do if you want to really get into the statistics of the time series. So we're going to extract the features. We're going to take the date, and we're going to extract the year, month, day, day of week, and weekday name from the date. And then we're going to establish our features, and then we're going to set the index with the end, and then we're going to look at the data frame that's created, and you can see that the end is your index, and then you've got close, year, month, day, day of week, and weekday. So this is a box plot of the months. So you can see all 12 months of the year, and you can see the activity for all 12 months of the year. Then we look at the year, so you can see the activity for the 4 years, 21, 22, 23, 24. You can see most of the activity was in 2024. You can see the activity for the day of the week, and on the activity for the day of the week, that you can see all of the activities is very close. We're going to do some time resampling. So we're going to resample it for the end of the year. And this is what the resample box bar chart of the end of the year looks like. We're going to resample it for the beginning of the year. And this is what your resampled bar chart looks like for the beginning of the year. Now we're going to resample for the months. So we're going to resample it for every month from 21 to 24, so you can see what the activity is for each month. Now what we're going to do is we're going to do rolling, and what the rolling does is it will smooth out the time series data. So we roll it for 1 because unfortunately it would not allow me to roll it to 0, so I had to roll it for 1, and then we will roll it for 30, and you can see how the time series has smoothed out when it's been rolled for 30. And again, that's something that you can study on your own if you want to learn how to do rolling and the reasons for it and when it would be applicable to do that. So now what we're going to do is we're going to get into the machine learning aspect of this. But what we're going to do is rather than using deep learning, which I've been using in my previous videos, now we're going to use sklearn's MLP regressor. That's a multi-layer perceptron regressor. And so we're going to create our features being end and close, and then we're going to create the data set. The end is your index, and then close is your univariate data. And then what we're going to do is we're going to make the data set go with the earliest date is going to be at the top of the data frame, and the latest date is going to be at the end of the data frame. So now after we've done that, we've got our data frame prepared. We're going to set the length of the training set. So the length of the training set is going to be 80% of the entire data frame. And then we're going to split the data set into training and validation sets. So the training data is 0 all the way to the length of the train set, and then the validation is length of the train set all the way to the end. And then what we're going to do is we're going to print the shape of these two sets. Shape of these two sets is 9761 and 2441. We're going to check validation data just to make sure that we've done it correctly. And you can see that the earliest date is at the top and the latest date is at the bottom of the data frame, which is what we want to see. Now what we're going to do is we're going to use the min-make scaler to scale it from all of the time series data from 0 to 1. And so we're going to do that on the training set and the validation set. And then after we have used the min-max scaler, that's sklearn, by the way, what we're going to do is we're going to create our X train, Y train. And then so what it's going to do is it's going to take the first 50 rows, and it's gonna break it down into X train, Y train to do that. And the reason why is because you want to take this univariate time series data and you want to convert it into a supervised learning model. And then so after we've done that, we're going to take the validation set and we're going to convert that into a supervised learning model using the same methodology that we used for the training set. And then after we've done that, then what we're going to do is we're going to take X train and we're going to convert it to a data frame, and Y train we're going to convert it to a series. We're going to take X val, convert it to a data frame, and Y val, convert it to a series. And then you can see X train, X, Y train, X val, Y val to look at the shape. Now what we're going to do is we're going to define our model, which is MLP regressor. So we're going to have 100, the hidden layer sizes is going to be 100, which is the default. The solver is going to be Atom, and I believe that's the default as well. The activation is going to be 10H. The random state is going to be 42, and max iterations is going to be 2000. And then we're going to fit X train, Y train. We're going to print the score using X train, Y train, and it's going to be 96%. It's less than it was when I was using the deep learning framework, but it's not too bad. So now we're going to predict on the validation set. So you can see all of our predictions on the validation set. And we're going to take we're going to reverse scale the Y val. We're going to reverse scale that to take it back to the original values. And then we're going to reverse scale the Y pred and then take that back to what would be the original values. Then we're going to check the error. The error is 2546, which isn't too bad. It's comparable to the deep learning errors. It's not as good as some of the deep learning errors, but it is comparable. So that's good. And then what we do is we create a data frame where you can compare the actual values against the predicted values if you want to see what they are. And then what we've done is we're going to use Matplotlib, and we're going to take the actual values and overlay them on the predicted values, and so you can see what that looks like. And then we're going to use Matplotlib, and we're going to plot the predicted values over the actual values, so you can see that. And it doesn't look too bad. I mean, the predictions that you get are comparable to what you would get using a deep learning framework, so that doesn't look too bad. So if you're not yet familiar with TensorFlow, or you don't feel confident using TensorFlow, or you just want to stick with sklearn, this is a method where you can use sklearn's only neural network to predict on the prices of Bitcoin. And I just thought I wanted to do this to give you lots of different options on how you can do that. So I'm going to go ahead and close this video for now. Thank you so much for watching it. If you like my video, please like and subscribe. I would like to thank my subscribers for supporting me, and I look forward to communicating with you in the next video.